In 7.2.1, we started cataloging the important characteristics, the very reliable characteristics of special quadrilaterals, those quadrilaterals that have distinct names. You rotated a triangle around the midpoint of one side, which gave you lines cut by a transversal and two pairs of alternate interior angles that were congruent. This was good justification for the fact that opposite sides were parallel and gives us a parallelogram every time we perform that rotation. 180-degree rotation through the midpoint of any side of a triangle will result in some kind of parallelogram. Sometimes parallelograms have more specific characteristics. Sometimes other quadrilaterals have more specific characteristics. In 7-5.1, a different transformation was performed, and that was the one pictured here. Kip did not rotate his triangles correctly in the problem. In fact, he did what? This is a reflection over the side of a triangle, which gives us a different figure. The figure we get is the kite. And what do the congruent triangles tell us about the angles of this particular shape? We can conclude a couple of things. So let's go ahead and start a page that looks like this. Make yourself a couple of boxes. We're going to catalog the information we've already discovered about parallelograms, as well as the information we are coming to understand about kites. The kite is defined as a quadrilateral with two distinct pairs of adjacent congruent sides. So let's take a look at that definition. By reflecting the triangle across any side, we can create a quadrilateral known as the kite, which is defined as a quadrilateral with two distinct pairs of consecutive congruent sides. The word distinct is an important qualifier in the definition of a kite because for our purposes, the square is not included in the kite family. The square certainly has two pairs of consecutive congruent sides, but they are not distinct. In other words, they have the same measure. All four sides, all four consecutive congruent sides are of equal measure. So square, not included in the kite family. And because a kite is created by reflection, we can tell a couple of things. One diagonal bisects two pairs of opposite angles. And please be writing this information down in a box in your notes that has a diagram of a kite. with the definition, a quadrilateral with two distinct pairs of congruent and consecutive sides. Where one diagonal bisects two pairs of opposite angles. That's what's happening here. And here. Because this is the height of the first triangle, and because the first triangle is reflected over the long side in this case, a copy of the height is projected into the second triangle, creating a diagonal that is bisected. So another characteristic of the kite, one diagonal bisects the other. Another characteristic of the diagonals is that they bisect each other. They are perpendicular. So one diagonal bisects the other. The diagonals are perpendicular. There are two distinct pairs of consecutive congruent sides, and one pair of opposite angles are congruent, or is congruent. One pair, opposite angles, is congruent. And what were those reliable parts for the parallelogram, whose definition is a quadrilateral, whose opposite sides are parallel, we started with a triangle, we rotated it 180 degrees through the midpoint of any side. Its angles were copied, and we can see that both pairs of opposite angles are congruent. Other reliable characteristic is that both pairs of opposite sides are congruent. And that leads us to a new conjecture about the diagonals of the parallelogram. Can we prove anything else about this figure? If I know opposite sides are congruent, And I know opposite sides are parallel. I'd like to be able to show that this piece is congruent to this piece, and that this piece is congruent to this piece, but I'm not certain I can say that. If I were able to show this triangle was congruent to this one, then I'd have the green piece and I'd have the blue piece. So let's go ahead and give that a try. This is certainly the kind of proof you'd be expected to make in Unit 7. So my givens are that BC is parallel to AD, that AB is parallel to CD, that BC is congruent to AD, that AB is congruent to DC. And those have been marked here. If these two lines are in fact parallel, I can use them to show that angle BAC is congruent to angle DCA by alternate interior angles. And if these two lines are parallel and also cut by transversal BD, I can use them to show that angle DBA is congruent to angle BDC, also by alternate interior angles. If AB is congruent to CD, that gives us one side. So I have a side. I have angle, side, angle congruence here. To say that triangle ABE is congruent to triangle CDE, and by corresponding parts of congruent triangles being congruent, I am able to say that segment AE is congruent to segment EC, that's here, and I'm able to say segment BE here is congruent to segment DE. So I can also say that the diagonals of a quadrilateral, or diagonals of a parallelogram, bisect each other. So get those special quadrilateral notes started and review the proofs. You'll be asked to prove other important reliable characteristics of quadrilaterals based on what you know about proving triangles congruent.